Hey Amanda, so we're going to start off here with P11. Now for P11, you need to find the missing side length that is indicated. Now this is, I have several examples here from this question, this IXL. Um, the level doesn't change, like it doesn't get any harder than the first ones that you get. So we're going to do a few and then we'll go over to Q2. So for this first one here, we're given this diagram. We are told that LM is 14 and MN is 11, and what is the value of KM? So when you have a right triangle inside of another right triangle, there are relationships that Delamo probably showed you. I'm not gonna lie, they're kind of hard to remember. So what I like to do instead is I like to draw out each of the triangles next to each other, the big one and the small one, and then I write down their corresponding sides. So we are told that LM is equal to 14 and MN is equal to 11. So we have this triangle that they're looking at, and then this triangle, and then we want to find KM. So the big triangle, the overall big triangle, is the one that we're focusing on here. So this one is going to be this big one, and then this one is going to be this one in here. So I'm going to label them. So this big one, this is K over here, M at the top, and L at the bottom here. So that's this big one. Then this little one, that's N here is the corner where the 90-degree is. L is the one that is across, and M is on the top. So LM is 14, and MN is 11. Now you'll notice that here we also have an LM, so this is also 14. And we are trying to find KM. So I'm going to find KM, which is this side here. So this is similar triangles, so we can create our ratios. I'm going to go big to small. So this side corresponds with this side, so 14 over 11 is going to equal to this side corresponding to this side. So x over 14. Now we cross multiply and we do 14 times 14 equals to 11x. So I'm going to go to my calculator. I'm going to do 14 times 14, which is 196, is going to equal to 11x. Divide the 11 and we get that x is equal to 196 divided by 11, which is 17.82. Now the questions tell you to round to the nearest hundredth, so that's 2 decimal points. That's why I rounded it to those 2 decimal points. So 17.82 would be the answer. Now over here we have WX, which is this side here, is 24. WY, which is this big one here, is 38. And then we're trying to figure out WZ, so this one. So since we're given this big side, I'm going to use this big triangle as my big triangle here. So the X is the 90 degrees, the Y is the top here, and the W is this corner. Then since we're trying to find WZ, that's this triangle. So now I'm going to draw out this triangle. So the Z is at the 90 degrees, the W is next to it, and then the X is at the top. So I'm going to label them now over here. So WX is 24. So this is 24 as well as this is 24 because this is also WX. And then WY, which is this diagonal here, is 38. And we want to figure out WZ. So this is the side that I'm trying to find. So we can set up our ratios now. I'm going to go big to small. So this side here corresponds with this side. So 38 over 24. And then this 24 corresponds with the WZ that I'm trying to find. So that's going to equal to 24 over WZ. Now what we can do here is cross multiply, again, just like we've been doing. Or if you want to do it in one swoop, the numbers that are in the diagonal, you multiply and then you divide by the leftover number. So I can do 24 times 24 divided by 38. So we have 24 times 24 divided by 38, and I end up with the answer of 15.16 since they wanted to round to the nearest hundredth. So 15.16. And that would be your answer. Let's try a couple more before going on to Q2. Here we have that Kn is equal to 7, Ln is equal to 5, and we want to find Mn. So since they give you side lengths for this triangle, and we're looking for a side length from this triangle, I'm going to use this one here and this one here. So this big one, that's N where the 90 degrees is, L is on the other side, and then the height would be K. In this little one, this one is easier to see because it's the same orientation. This is N, this is M, and this is L. So now we label. Kn is 7. Ln is 5, which this also has Ln, so this is also 5. And I want to find Mn, so I'm going to call that X. So now we create our ratio. Again, since I have my triangles big to small, I'm always going to go big to small. So 7 over 5, because the 7 corresponds with the 5, is going to equal to 5 over x. Again, we can do this in one clean swoop. We multiply the diagonal, so 5 times 5, and then divide by the 7. 5 times 5 is 25, divided by 7. Come here to the calculator. And we get 3.57, again rounding to 2 decimal points. Last one for P11. We have here that Jm is equal to 14 and Km is equal to 12, and we want to find Lm. So again, we're using this small one here, this one here, the one on the left, and we're using this triangle here on the left, on the right. So I'm going to label this triangle. The 90 degrees is the M, the short side goes to K, and the long side goes to J. For the little one, this is M, L, and this is K. So now let's label. JM is 14. KM is 12, which we have a KM here as well, so this is also 12. And we want to find LM, so this will be X. So I'm going to create my ratio. I'm going from small to big, so 14 over 12 is going to equal to 12 over X, since those are corresponding sides. So again, we cross multiply, or multiply the diagonal, which 12 times 12 is 144, and then divide by the 14. So I'm going to come here to my calculator now. Remember, we need to round to the nearest hundredth. So 144 divided by 14 is going to equal to 10.29. And that would be my final answer. Now let's go on to Q2. Q2 is the converse of the Pythagorean theorem. Now this is your Pythagorean theorem, and we use it to solve for a missing side. However, for this IXL, which is the converse of the Pythagorean theorem, that means that we can prove that a triangle is a right triangle if it satisfies the Pythagorean theorem, which is a squared plus b squared is equal to c squared. A and b are your side lengths. It does not matter which one you make A or which one you make B. This could be B and this could be A. That does not matter. But C is always the hypotenuse, which is the longest side of your triangle. So if a triangle has side lengths of 3, 4, and 6 millimeters, is it a right triangle? So I'm going to use the Pythagorean theorem. I look for my longest side. That will be C. These two will be A and B. So we do 3 squared plus 4 squared, and that has to equal to 6 squared in order for it to be a right triangle. 3 squared is 9, plus 4 squared is 16, and that should equal to 36. 9 plus 16 is 25, and 25 does not equal to 36, so no, this would not be a right triangle. Now for this one, we have 8, 15, and 17, and is it a right triangle? Again, I look for my longest side, and that is C. So we do 8 squared plus 15 squared is equal to 17 squared. 8 squared is 64, plus 15 squared, which is 225. And that should equal to 17 squared, which is 289. If I add 64 plus 225, I get 289. And since 289 does equal to 289, that means that yes, this is a right triangle. Let's do a couple more. A triangle has side lengths of 10, 24, and 26. Again, I look for my longest side. This is C. So 10 squared plus 24 squared should equal to 26 squared if it is a right triangle. 10 squared is 100 plus 24 squared, which is 576. And this should equal to 26 squared, which is 676. If I add these, I get 676, which does equal to 676. So yes, this would be a right triangle. Last one, we have 25, 97, and 100. This is my longest side, so this is C. So I do 25 squared plus 97 squared, and that should equal to 100 squared. 25 squared is 625, plus 97 squared is 9,409. And that should equal to 100 squared, which is 10,000. If I add these two together, 625 plus 9,409, I get 10,034, which does not equal to 10,000. Therefore, no, this is not a right triangle. And that's basically it. And that's all you do for the rest of this IXL. So that's P11 and Q2.